Have you ever asked an AI a question and felt like you could, I don't know, go make a cup of coffee while you wait for the answer? Yeah, it's a super common frustration. But here's the thing, it really doesn't have to be that way. Today, we're going to dive into how a totally different way of thinking, concurrency, can make AI agents so much faster and more efficient. Let's see how it all works. So, the root of the problem is what I like to call the sequential trap. You see, most AI agents work like a single lane road. They call one tool, they wait, it finishes, then they call the next tool and wait again. Now, each little step might be pretty quick on its own, but that total wait time, man, it just adds up. And that's what leads to that slow, clunky experience for us. Makes sense, sure, but it's just not efficient. To really get a handle on how we can fix this, we're going to follow one simple question on its journey from start to finish. This is going to make the whole technical challenge a lot more real. All right, so here's our question. What is the weather and activities in San Francisco? Super straightforward, right? It's something you or I might ask any digital assistant, but behind the scenes, it's actually not just one single job. You see, to get a complete answer, the AI has to do two totally different things. It needs to call a tool to get the weather, and then it needs to call another completely separate tool to find some local activities. In that old sequential world, this means one task just has to sit there and wait for the other one to finish first. So, how do we escape this trap? Well, the solution is in a whole new way of thinking, a concept we can call the asynchronous advantage. And this is where the Agno agent comes in. Think of it less like a worker on an assembly line and more like an orchestra conductor. Its main job is to get all the different tools, which in this case are async generator functions in Python, ready to play at the exact same time. It doesn't run them one by one, it orchestrates them. Now, the real magic behind this is something called asynchronous design. In Python, you use keywords like async and await, and what they let the agent do is pretty cool. It can kick off a task, like, say, fetching those activities, and then immediately move on to the next thing without waiting. These tools are built as async generators, meaning they can yield results as they become available rather than waiting until everything is done. It's non blocking, which is just a fancy way of saying the whole system doesn't grind to a halt just because one slow part is taking its sweet time. And here's what that looks like in practice. With the old method, the agent would fetch the weather. That takes 1 second. Then it would fetch the activities, another 3 seconds. Total time, 4 seconds. 4 seconds of your user just sitting there waiting. But with the new approach, we both start at the exact same time. The total wait time is now only as long as the slowest does. We just saved a full second, just like that. Think of it like a smart kitchen. You start the coffee maker and the toaster at the same time. You don't wait for one to finish before starting the other. That's the power of parallel execution. Okay, that all sounds great in theory, right? But let's actually watch this happen in real time. We're going to take a peek under the hood and see exactly how the agent pulls this off. The journey begins with agent.aaron. This is the method that kicks off the asynchronous generator. You pass in your user's question, set stream equals true, and importantly, stream events equals true. This is how we get to see the magic as it happens. To see what's really going on, we're using a feature called event streaming. Honestly, you can just think of it like a live fly tracker for our AI. It gives us a perfect real time log of every single step the agent is taking, when it starts, when it calls a tool, and when that tool is done. And we're off at time zero, the very instant we ask the question, the run starts. Starting agent run, 0 seconds, run started, no delay whatsoever. The clock starts now. Now, here it is. This is the crucial moment. Just 1/100th of a second later, look at what happens. 0.01 second, tool started get weather. 0.01 seconds, tool started get activities. The agent calls both tools simultaneously. It doesn't do one, then the other. It fires them both off at the same time. This is the heart of Agno's concurrency model. Okay, now we are at the 1 second mark. The faster tool, the weather one, it's already finished and yielded its result back. 1.01 seconds. Tool called completed, get weather. But the activities tool, it's still chugging along in the background. And that's totally fine. The system keeps moving. Hmm. And finally, at about 3 seconds in, the slower tool completes its job. 3.01 seconds, tool call completed, get activities. Total execution time, 3.02 seconds. The very moment that second result is in, the agent instantly assembles the final response. The total time was only as long as the slowest task, not the sum of everything. So, what does this all add up to? What's the big payoff here? Well, it's about so much more than just shaving off a second. A 25% reduction in wait time. That's a drop from 4 seconds all the way down to 3. And you know what the best part is for the developer who built this? This huge improvement happened with zero changes to the actual code for the tools. The framework just handled all the orchestration automatically. At the same tools, faster execution, no extra complexity. And this really gets at a much bigger idea. Concurrency isn't just a neat trick for getting more speed. The architecture is built on three core Python primitives. Async and await defines non-blocking functions, allowing the event loop to manage tasks efficiently. Agent.run, the entry point that kicks off the asynchronous generator and manages concurrent tool calls. Async for the syntax for consuming that real-time event stream. Think of it like this. The agent is a project manager giving tasks to specialists, your async generator tools, and tracking their progress live through event streaming. When you enable an agent to talk to multiple systems at once, databases, APIs, file systems, different services, you're fundamentally changing what it's capable of. We're not just making it faster, we're literally building the architecture for a more robust and responsive intelligence. The agent is no longer just a simple task executor blindly following a to do list. It becomes a true orchestrator managing complex parallel tasks to interact with the world in a much more efficient way. And this leaves us with a really fascinating question to think about. If this parallel concurrent approach is the true architecture of intelligence, what kind of new possibilities does that open up? What are we going to build when our AI is no longer stuck in the slow lane and can finally think as fast as the world actually moves? If you found this helpful, don't forget to subscribe. I'm sharing more content like this to help you on your AI journey. See you in the next one.